So let's talk about literal equations. So a literal equation is simply an equation that has a variable that is representing a number. Now we've seen that before, right? We've seen x's and y's. And so what happens is we have equations or inequalities that can have more than one variable. We've already seen that. We've seen y equals, we've seen x equals. But when we've solved, we have dealt with things that only have one variable that we've solved for. In a literal equation, because there are multiple variables, we will first have to identify the variable that we're trying to isolate. And just like when we solved when it was just for x, we're going to perform inverse operations on all the other numbers and variables. So let's look at some examples. So we're going to do these two at the same time because there are some parallels. So on the left hand side we see solve 3x plus 2 equals 14. And this is something that we have practiced solving before. On the other side we have something similar. Instead of 3x it's ax, instead of plus 2 we have plus b, and instead of equal to 14 we have equal to c. But in both of these problems, you'll notice that we are solving for x. So let's start on the left-hand side. If we were trying to isolate x and get x by itself, what's the first thing that we should do? We would want to subtract 2 from both sides. Because remember, if we do something to one side, we have to do it to the other. And so we would solve, right? 3x, there was no other x's, so that stays 3x. Plus 2 minus 2 cancels each other out, and 14 minus 2 is equal to 12. Now, I want us to look at this other problem on the other hand side. Again, what we're trying to do is get x all by itself. And just like on the left-hand side, what's in the way? Well, it's not a number, but it's a variable. So we can subtract b from both sides. And so what happens? There's nothing with the ax, so that stays the same. B minus b cancels each other out, right? And on the left-hand side, we could actually perform the math. 14 minus 2 was 12. On the right-hand side, c minus b. Well, we don't know what that is, so we literally can just write c minus b. See, literal equations, we literally write it. Now, we haven't actually gotten x by itself yet. There is one more thing that we need to do to get x by itself. We have to divide both sides by 3, right? This is 3 times x, and we can undo that multiplication with division, right? 3 divided by 3 is going to cancel, and so that leaves us with 12 divided by 3, which is 4. On the right hand side, again, we're trying to isolate the x, and the idea is similar here. On the left hand side we had a 3, on the right hand side we have an a, but it's still a times x, and we want to be able to undo that, so we're going to divide both sides by a. Now, the a's are going to cancel out and we have x equals, but unlike on the left-hand side where we got a nice pretty number, there's nothing we can do here. These are not like terms, so we can just write down the equation as is, c minus b divided by a. So the idea, the process of solving an equation is the exact same for a literal equation. We're just not going to end up with a numerical answer. But let's look at a few more examples. So, solve 5 times x plus a equals y for a. We want to try and get a by itself. And we need to first think what's in the way of having a by itself. Well, this 5x. Now remember, there's an understood addition sign in front of here. And so the 5x is being added to the equation. We can undo addition with subtraction. So we're going to subtract 5x from both sides. Positive 5x minus 5x, those undo each other, right? That's why we subtracted from both sides. So we have a on the left-hand side. And now there's nothing we can do here. Y and negative 5x are not like terms, so we can just say y minus 5x. We could also write this, if we wanted our x's to be first, as negative 5x plus y. Both of these equations are what we call equivalent equations. Now, have we done what was asked? Did we get A by itself? A, nothing else. We sure did. So there's our answer. Now let's look at another one. Again, we're going to solve 2 times x plus 3 times y equals 8. And this time we want to solve for x. So we need to figure out how can we get the other things on the left-hand side to the other side. There is a 2 in front of our x, but there's also a plus 3y. And we always want to start with any addition or subtraction. So we're going to start by subtracting 3y from both sides. There was nothing with the 2x, so it's going to stay the same. 3y minus 3y, they undo each other. We're left with 0. And on the right-hand side, these are not like terms. So we can just say 8 minus 3y. Or we could say that 2x is equal to negative 3y plus 8, if you prefer having your variables first. But do we have x completely by itself? Not yet, right? The 2 is still in front here, right? This is 2 times x, so we need to get rid of that 2. And we can undo multiplication with division. So we're going to divide both sides by 2. 2 divided by 2 is just 1, so we're left with just x equals. Now, with a fraction like this, we have a couple of options. We can just take it literally as it is, right? One big fraction, all divided by 2. Or we can treat each individual piece as an answer. So we can say x equals, and then we would look at what happens with negative 3y divided by 2. Right? Negative 3 divided by 2 does not simplify, so we can just say negative 3/2 y. And then we could also look at 8 divided by 2, which gives us plus 4. Both of these answers work. Again, they are what we call equivalent equations. My T on there. All right, let's look at a few more just for good measure. So this problem we have some with division, and so we have x equals 3 times z divided by y, and we're trying to get this z by itself. So first, anytime I see a fraction, I want to get rid of it. And how can we undo a fraction? Well, a fraction is just division. And how do we undo division? With multiplication. So we're going to start, take our equation, and we're going to start by multiplying both sides by that denominator that we want to get rid of. So on the left-hand side, that's just xy. Right, or y times x, whichever way you want to write that. But on the right-hand side, the reason why we multiplied by y is so that the y's would undo each other. We had 1 in the numerator and 1 in the denominator. They're going to cancel each other out. And so then we're left with just 3 times z. Well, is z by itself? Not yet. So what do we need to do? This is 3 times z. So now we're going to undo that division. Oops. Undo that division with, or undo that multiplication with division. So we're going to divide both sides by 3. So let's start on the right-hand side because that's where we were trying to isolate z. 3 divided by 3 is going to cancel out, so we're left with just z. And on the left-hand side, there are no like terms here, so it's just going to say xy divided by 3. See what you can do for the problem on the right-hand side. You can pause the video and try it on your own, and then come back and see if your answer matches. Alright, so hopefully you tried this problem for yourself, trying to get y by itself. So the first thing we would want to do is subtract the 2w from both sides. So the 2w minus 2w is going to leave us with 0, so negative 8y equals z minus 2w. But the y isn't by itself yet, so we need to get rid of that multiplication, and we're going to divide everything by negative 8. So a couple of different ways that we can write this here. Negative 8 divided by negative 8 is just 1. So one way we can just say y equals and write it exactly as we see it. Z minus 2w divided by negative 8. Sometimes, though, we like to have the negative out front. So another way that we could write this answer that would be equivalent is y equals, and we're going to put that negative out front, and then parentheses, z minus 2w all divided by 8. And the parentheses there just kind of help keep things straight so that we don't lose that negative sign. There's one more way that we could actually write this, and looking at each individual piece. So we could take z divided by negative 8, which would be negative 1/8 z, and then we can take negative 2w divided by negative 8, and a negative divided by a negative is going to give us a positive, and we can simplify 2 divided by 8 to be 1/4, so we end up with w divided by 4. Hope this helps.